Hello, and welcome to the demonstration of the final version of my project cracking project developed in C. Finally finished, everything's at 100% and working how it should be. So a brief overview, this project involves implementing two different methods for password cracking. One would be brute force, and the other would be hill climbing. The program demonstrates key concepts such as input validation, algorithm optimization, along with secure code practices. Throughout the development process, I made several improvements, including refining the algorithms, improving the user input handling, and optimizing the overall performance of the program. So, with all that being said, I'll go ahead and get into the video and go further along with my explanations, explaining the key changes made, provide insights into the functionality of the project, along with showcase its execution through a live demonstration. So to go ahead and start, let me first go ahead and explain what this program does. So when you run the program, you'll be greeted with a menu that provides three options. The first one is the brute force cracker, and that method systematically tries every possible character combination until the correct password is found. The second one would be the hill climbing cracker. This method is more efficient as it starts with a random guess and adjusts its character character by character until the password matches. And then the last option that's provided would be allowing the user to exit the program. So when you choose an option, the program prompts you into an input target password up to 10 characters long. The program then uses the selected method to guess the password. Once the password is cracked, the program displays the password has been cracked, the number of attempts it took, along with the total of time taken to crack. So this project showcases both brute force methods and the efficiency of the approach, such as hill climbing, while also emphasizing secure input handling along with performance monitoring. So now that we got the project overview out of the way, let me go ahead into the key changes on the code along with the justifications behind them. So the first thing was the input validation. In the beginning, the program lacked input validation, which led to issues like accepting invalid menu options or overly long passwords that could cause buffer flows. So in order to resolve this, I added checks to ensure that the menu input is numeric and falls within the valid range of 1 through 3, I should say. So if the input is invalid, the program inputs the user to try again, and it clears the input buffer to prevent any further errors. For the password input, I limited the length to 10 characters. Even if the user enters more, the program safely ensures that will be null terminated. This prevents memory issues and aligns with the secure coding practices. Not only that, but I also included scanf_s for secure input. So the original scanf posed security threats as it didn't check the input length, making the program susceptible to buffer overflow attacks. So going more into the improvements, I refined both the brute force along with the hill climbing algorithms to improve their functionality as well as their efficiency. So with the brute force, this method generates random guesses of the same length as the password. I enhanced it by clearly outputting each guess and tracking the number of attempts that it took in real time. While it remains expansive, it's now easier to observe and analyze its process. When it comes to the hill climbing, the algorithm starts with a random guess and then corrects the incorrect characters. I optimized it to replace only the mismatched characters in each section, which significantly reduced the redundant operations. These updates made it more efficient without taking away from the accuracy of each of the attempts. Lastly, to improve the user experience, I updated the program's output to make it more informative as well as user-friendly. The results would include password crack, the number of attempts took, along with the time taken. Not only that, but the menu now includes clear instructions to guide the user through the options, making the program easy to use even for beginners. So with all that being said, let's go ahead and see a live demonstration of the program in action. I'll go ahead and demonstrate its functionality by running it and showing how it handles different inputs along with cracking methods. So our first option for the brute force cracker, we'll go ahead and use the password ABC123. So as you can see, the program is generating random guesses and comparing each one to the target password. It displays each attempt on the screen along with the attempt count. When it finds the correct password, it stops and displays the correct password, the total attempts, and the time taken. So this demonstrates the nature of the brute force. For a short password, it works pretty fast, but as the length increases, the time continues to rise because now there's more options to choose from. Going into the hill climbing cracker, which is option 2, we'll use the password hello123. So unlike the brute force, this method starts with a random guess and corrects individual characters, and you can observe the guess improving step by step until it matches the target password. Once the password's cracked, the program again outputs the results, including the correct password, attempts, and time taken, just as it does in the brute force. So this approach is much faster for longer passwords because it focuses on making small changes rather than trying to use every combination that's possible. So lastly, we'll go ahead and demonstrate the program's input validation when it comes to entering an invalid option. So if we go ahead and press 5, the program rejects it and prompts me to enter a valid choice. That's because there's only 3 options that you can choose from, 1, 2, or 3, and 5 is not along one of those, so we can't go ahead and do that. So to wrap up this whole project, it not only demonstrates my understanding of algorithm design along with the implementation, but it also shows the commitment to writing secure, efficient, along with user-friendly code. It's honestly been very rewarding to go ahead and do a project like this. I had my doubts in the beginning, but seeing the project develop stage by stage, step by step, making the adjustments, and then finally seeing the project come together as a whole and work properly and efficiently as intended, it's been a rewarding experience for me. I honestly enjoyed this very much. I hope y'all enjoyed it as well. But thank you again for watching the demonstration, and I appreciate everything that I've learned from this, and I really want to learn more about this now because it's piqued my interest very much, seeing that I can do it just with a little bit of research and practice. Anything's possible. So thank you again for watching my presentation.